Welcome folks, in this video we are going to look at naming and memorizing polyatomic ions. Now first, before we look at these ions, let's first define what an ion is. So an ion can be defined as a charged atom or group of atoms. Right, so now before an atom becomes an ion, it is electrically neutral because the number of electrons equals the number of protons. For example, if we have sodium with the mass number of 23, then the atomic number of 11. So 11 denotes that there are 11 electrons and also 11 protons. So if we are to do the math, we know that minus 11 plus 11 will give us 0. So to simplify what we are looking at here, we are saying as long as the number of protons equals the number of electrons, then an atom is electrically neutral. Now for an ion, the number of electrons does not equal the number of protons. For example, if we have n plus simply means that there are 11 protons but 10 electrons, so there is an extra proton. Now if you look at the chloride ion has for protons we have 17, then for electrons we have 18. So after the losing or gaining of electrons, the number of electrons does not equal the number of protons, thus we have an ion. So an ion is an atom that is charged, or a group of ions. Now after that, we can now look at the definition for a polyatomic ion. Remember, we have monatomic. So from the word polyatomic ion, we have the first prefix poly. Poly simply means many. Then if you look at monatomic ion, so for monatomic, mono simply means one. So for monatomic ion, we are looking at ions with only one type of atom, but for polyatomic ions, we are looking at an ion with two or more atoms. Now you need to memorize the polyatomic ions and some of the monatomic ions that we are going to look at. Then we are going to use some of the tricks that can help you to memorize these ions, and also the charge that I'll be putting here also indicates the valence number. For example, if we look at the sulfate SO4, then we have the charge of -2. So if you are looking at how to write the chemical formula of a compound, then this 2 is treated as a valence. For example, if we have sodium with a valence of 1, then sulfate with a valence of 2. So if we use the crisscross method, this will give us sodium sulfate as this one. So the charges, when it comes to writing the chemical formula, they are used as the valences, right? Now away from this, the first step that I'm going to look at is most of the monatomic ions, most but not always, most of the atomic ions ends with IDE. So this is the suffix that we are going to look into consideration, like sulfide, chloride, nitride, carbide. So whenever you see IDE, it means that you are dealing with a monatomic ion. Then for polyatomic ions, we have different names. We'll look at that later. But there is one trick that I think can be of help. So say ATE, this one has one extra oxygen atom 8. Right now, let's dive right into examples. So let's look at the first one. So look at the first one. We'll look at this one. Then we'll have another one. So whenever we are not, if the number is not shown, if you only see a negative, it means there is a -1, so the valence is 1. Then for this one, we are going to have this. So if you look at the point here, under this one, there are 3 oxygen atoms, but in this one, there are only 2 oxygen atoms. So what are we looking at? We are saying the first one, this one, is known as a nitrate. Then the second one, since there is less oxygen atom, this one is called nitrite. So that's a key point. So whenever we see 8, it means there are more oxygen atoms compared to 8. Then for the last one, we can see that this is a monatomic ion. So for this one, you just have to say nitride. So this one will end with IDE. Right. So let's move on to the next one. So the next one, we have SO4 and SO3. Feel free to pause the video and give it a try. Then we have S2. Right, so the first one, we get the name of this one. So this one is sulfur, but we're going to call this one as the sulfate. Then for this one, since we have 1 less oxygen, we are going to call this one as a sulfite. Then for this one, it's a monatomic ion, so this is a sulfide. So let's hope by now you've gotten the concept here. Right, we move on to, we'll deal with now this one, PO4 with 3 minus, PO3 with 3 minus, then P with 3 minus. So the one thing in common of these polyatomic ions and the monatomic ions for this is that they have the same valence number, which is 3. Then for this one, this is called a phosphate. Then here, since we have a 3, so this is called phosphite. Then for this one, there is no oxygen, we are going to call this one phosphide. Right, we move on to the fourth one. We have Cl minus excuse me, Cl minus, then we have Cl2 minus 1, Cl3, then Cl4 with minus 1. So the first one is a monatomic ion, so this is a chloride. Then I'm going to name the third one, I mean this one. So this one will be called a chlorate. So since here there is 3 atoms of oxygen and here there is 2, so this one will be called chlorite. Then now what happens to these? So for this one, since this one it shows that there is only 1, so this one is less than these 2. So for this one, what you have to do is you need to add hypo. So this is now called hypochlorite. Then for this one, we can see that we have 1 extra oxygen compared to chlorate. So this one, you just have to say perchlorate. Right, we move on to this one. So we have Br minus, then we have Br O minus, Br O minus 2, Br O minus 3, then Br or minus 4. So for halogens, so whenever you have a group 7, the pattern is always the same. So for this one, we know that it's a monatomic, so we're going to consider this one as a bromide. Then for this one will be bromate. So if this is bromate, then this one is bromite. Then this one will give us hypobromite. We have perbromate. We move on. Let's look at where we have the iodine. So this is also group 7. So for the first one, this is the iodide. It's monatomic, so we have iodide. Then for this one will be iodate. We'll have iodite. Then hypoiodite. Iodate. Now away from this, let's look at this one. So we have CO3, 2 minus, then even this one, but this one we have a 1 minus. This is called carbonate. Then since here we have the hydrogen, this is known as so this one is known as hydrogen carbonate. Then sometimes you may call it bicarbonate. So similar, let's say this is our sulfate. Now if there is hydrogen, so this will be called, so the first one will have sulfate, then this one will be called hydrogen sulfate. Away from there, we can also look at this one. So this is there is hydroxide. So the first one is from the hydrogen. Then whenever we have oxide, we need to look at oxygen. Then we have NH4 plus. Never confuse this one to this NH3. So NH3, this is just a gas, it's ammonia, it's not an ion. So it's ammonia. Then for this one is ammonium. Right, so this is what you can use whenever you are looking at polyatomic ions. So remember, these are very important. You might need them in future. And also, the other importance of this is that the charges that we have been using for these ions can be used as the valences whenever you're writing a chemical formula. So that's it for this video. Thanks for watching.